This is an interpretive video guide of forest evidence concepts created by students in the Environmental Studies and Outdoor Education class at Thetford Academy. I hope you enjoy this video as the students guide you through forest evidence concepts they learned about by reading Tom Wessel's books, Reading the Forested Landscape, and through many interpretive walks through our Vermont forest.
This is a stone wall. They were starting to build in 1810. They were used for keeping livestock in and farming. For farming, they would, when they were digging up plots of land to plant, they would find little stones, so they would put them on top of each other to signal the plot of land. And they would use bigger stones for livestock. The stone walls would be, if they were used for livestock, they would be pretty tall, and if they were used for farming, they would be down low. A large shipment of sheep were transported here, and that led to there being 1 million sheep, and so the stone walls were very important so that there wasn't a whole bunch of sheep running around.
So what I have here is a nice weevilled, magnificent white pine. There are a couple of reasons why it is weevilled. One, because of the sunlight. So there are a lot of trees around here now, but I'd say about 150 years ago, there were not as many trees as there are around now. Maybe a few, but not many. So there was direct sunlight right here. There is a native bug called the weevil. The weevil is a little bug that chews through the terminal shoot. I think that's the right word. It's on the top of a little tree, or on top of the tree in general. So the branches turn into like the part of the trunk. So part of the trunk is there's like a big gap in it. That's mainly because of the weevil bug. It's not a dangerous species. It is, like I said, it's native to here.
This right here, this is my wolf tree. Now, you might wonder, why is it called a wolf tree? It's because they're like, when you think of a wolf, you're thinking, oh, lone wolf, like big, strong, tough. And that's kind of like what this tree is. But like, it had to get to that point somehow. If you look around at all the other trees, they're all like tall, small, they're still pretty skinny, and all their branches are shooting straight up. It's because they're all fighting for sunlight, because there's a lot of trees in here. They got a lot to compete with. But if you look at this tree, its branches, they're spreading out. I mean, obviously there's some on the ground now, but like the ones that are still there, they're like wide. Because that's because this tree was out in the open. So it didn't have to fight for sunlight. Its crown, it could just spread, go wide. And so that's how it became a wolf tree. That's pretty much what a wolf tree is. But because of that, we know that this land was open. Because for it to be in complete sunlight, it had to have room and sunlight. So this land must have been field, pasture, something. So this tree was most likely a shade tree, because we know it's about 200 years old, which brings us back to around the 1830s, which was sheep fever time. So there's probably some sheep around here, and this is probably some shade for them and other things. But if we look at it now, it's like low now, there's not as many branches. Because this tree is now, that the forest is starting to grow up, it's starting to grow up because it wants to survive still. So it started to grow up, and so now its wide branches are closer to the top and doesn't have as much down low.
Basal scar. It's from logging, not fire. You can tell on which side of the hill it's on, and it's on a logging road, and there's a bunch of stumps everywhere that you can tell it was logging, and it wasn't clear cut. It was selective cut because there's not stumps everywhere. They're kind of just sporadic everywhere. They're not just one area. And you can tell this is a logging road because it's so wide, and it's where something rubbed the tree up, like a skater rubbed the tree against it, and it made the basal scar. And sometimes it'll heal over, but it doesn't. It'll rot the inside of the tree out and leave this scar in it. And this ties in with like the age thing. The trees are not huge. Like, if it wasn't logged, the trees would be huge. But you can clearly see it on logged because the trees are smaller.
Alright, so this is a frost crack. This happens in the winter when the sun is beating on it and it warms the tree up and the tree expands, and then as soon as the sun goes down over the hill and it gets dark, it gets cold really quick and it causes that crack up the tree. And you can see it's on a birch, and birch and beech are more susceptible to frost cracks because they have smooth bark, whereas if you look at all the trees around, they have little grooves in the bark, so it gives them more room to contract, and so they don't get frost cracks. Beech are more susceptible to frost cracks because, again, they have smooth bark. But the thing between birch and beech is, since they have white and light colored bark, they kind of reflect the sunlight, and that causes them to stay colder. But obviously you can see this one did not do a good job of protecting themselves. And beech, they adapted from the tropics, so when they came over they were not used to the cold weather, so they all got frost cracks, but they eventually adapted, and they adapted by their leaves kind of helped them. They got like a waxy coat to protect themselves from winter and cold weather. That's why if you look at the beech, they kind of have their leaves longer than most. And beech also have more wide-spreading roots, so that causes it to take in more moisture.
Okay, so my forest evidence concept is about stumps, and this is a sugar maple stump. And a way that I like narrow down what it could be is I use like an elimination method. So I eliminate trees that it can't be, which is like oak, locust, and American chestnut, because they are rot resistant and they rot from the inside out, which is not happening right here, versus like beeches, birches, and maples, which they rot uniformly all throughout, which is happening right here. And they also are like more commonly like have the black fungus around it on the stump. But also, judging by the trees around it, I would say that this is like a sugar maple. I also think this tree was cut around like 25 to 30 years ago. So it's also like when the stumps would completely start to decay. And there's also a basal scar over there on that tree, which that tree looks no more than like 50 to 55 years old. Basal scars are also another thing of like saying there was potential logging here, and I think that there was selective logging here, judging by like there was these big trees over here, which looks like they've been here for a long time, and also that tree down there that looks rotted is also another sugar maple. Another way you could tell that it's logged is because how like straight this is. Usually they wouldn't log this high up unless it was during winter, so that means like this tree was logged during the winter season. And also I had mentioned that there's black fungus on this because the wood looks charred, but it's not. It's like a species of ascomycetes. It's like a black fungus. So it's usually commonly misled as charcoal. But with charcoal, like if you rub it with your fingers, it would smear, but the black fungus doesn't.
This is my tree. My tree is a coppice red maple. Now, coppicing occurs when a tree is either cut down or burnt, and after these events happen, the tree stump will sprout extra like stems or sticks or trunks, if you want to call them that, and it will form a multi-trunk tree. Sometimes the coppice tree will look like just a tightly packed group of trees, but this one, you can obviously see that the trunk is around here. A fun fact about coppice trees is that if you go around the entire area of the tree, you can tell roughly the size the original tree was when it died. Now, coppice trees can indicate maybe a fire or logging. I personally think it was logging because you can see along the hill there aren't basal scars, which will indicate fire because of the buildup of leaf litter at the base of the trees against the hill, which will burn harder, causing the basal scar. But you can see along the trail basal scars, which are indication of that this was a logging trail. You can also see specifically only red maples being cut down, like one over there, one over there, and one over there, showing that they were specifically cutting down red maples. I don't know why they were cutting down red maples specifically, but they were probably for firewood, given that it was in colder years and this was mostly a field at the time. Some trees make coppice better than other trees. Some of the trees that coppice the best in Vermont were the hazelnut and chestnut, although those aren't around as much anymore.
This is a blowdown. It was a dead blowdown. I know this because there is no dirt pulled up with their roots. If there was more dirt on the roots, then it would have most likely been alive. It's a hemlock blowdown. I can tell by the trees around it being hemlock and its rotting pattern from outside in. This tree blew down to the northeast, which means it was a thunderstorm that caused it. If it was to the northwest, it would have been a hurricane.
So this is a beech snap. To know how a beech snap happened, you gotta know about the little stories and all the different parts. It starts with the beech blight, which is a little scale insect that pierces a hole in the bark of the tree because it wants to feed. And then there's this fungus that travels by wind, and it gets in the little piercings that those little bugs created, and it grows throughout the tree, and it weakens it, and it slowly kills it, and it disrupts its bark. And that's just the beech blight. And so at that point the tree is dead. And then there's the secondary rot fungus, which is like all of that little stuff in this. That's just basically the fungus that grows on rotting trees. And then the carpenter ants move in, and they dig little tunnels that you can see in here, and they make their little home. And then there's woodpeckers that they want to eat the carpenter ants, so they peck the tree, and eventually the tree just gets so stressed out from all of these things happening, because there's a lot of things that happen, and it just snaps right off. And it usually snaps about like halfway between the base of the trunk and where the branches start. This one snapped a little lower, but it depends. All beech trees have the beech blight, and beech snap basically is just proof that the beech blight is present in this forest. And beech trees are never going to get to this size again because the beech blight will kill them before they can get to this point, and most likely cause beech snap on them. You're always going to see beech trees though, because they're resilient, and if the tree senses that something is happening to it, it will root sprout. So a bunch of little trees will grow out of the same roots. And so there's always gonna be beech trees, but they're never gonna get to this size again. So this is kind of unique.
This is my example of a nurse pillow and a tree that grew over it. A nurse log is the same thing as a nurse pillow, but it's when a fallen tree grows a layer of moss, which takes about 10 years, and in that moss, other trees and other species are able to germinate and grow. Two very common trees that grow off of nurse logs are eastern hemlocks and yellow birches, like this one. That's because their seeds are so small that they have a hard time growing up out of the leaf litter. So like the safety of the moss gives them protection and a environment for them to grow. This is an example of a tree, a yellow birch that grew on a fallen tree from the hurricane of 1938. You can tell because the way that the tree grew, you can tell the tree fell northwest, meaning that the wind came from the southeast, which is an example of a hurricane. By the way, like the root system is, and it's like over, you can tell it sprouted and germinated out of the existing moss on the existing tree. And then it grew, and as that existing tree decomposed, the yellow birch used its nutrients and had protection and shelter from the outside, and it grew tall, and now the fallen tree is all gone, leaving this above ground root pattern from that. The yellow birch grew off of these nurse pillows. This is a pillow, and that's a cradle. This pillow and cradle was from the hurricane of 1938. You can tell that by the way it fell, the direction it fell. The tree fell northwest, and the wind came from southeast, this way. You can also look around and see there's a lot of other pillows and cradles. The other way that tells you this was a big hurricane was this is a really big pillow and cradle. So it's a big tree, so it had to be a lot of wind. It's very strong. Pillows can happen from a couple of different things. One of the things that they can form because of is when the ice age, there were rocks trapped in the ice, and then when the ice all melted, there's a lot of these really big, really old boulders, and moss covered them, and then they can create pillows. There can also be from water, where there's water that pools in a place where there's trees, and then the roots kind of create pillows and cradles where the roots help work together. Other ways you can tell what each pillow and cradle is from. There are winter storms, which the wind comes from the northwest, and the trees fall southeast. There are also tornadoes, which the trees fall in all different directions. And also that's not very common around here. And they also don't always pull out the whole tree. It sometimes just breaks off halfway. And also the land, by just the fact that there are pillows and cradles, you can know that it wasn't plowed since 1938.